So before inviting our speaker for the session, I would like to give their brief introduction to the audience. Professor Marcus Watson is an honorary professor in the Faculty of Health and Behavioral Sciences at the University of Queensland, where he leads research on human factors, education, and design. Professor Marcus has extensive knowledge of simulations and is a national leader in simulation based research. He has delivered keynotes, plenaries, and workshops, including simulations development, serious games, online learning, and human factors in healthcare. He has extensive experience as a developer and instructor working with computer based simulation, high end immersive simulation, serious games, and distributed learning. He has received national awards for innovation based on his work in simulation. It's a great pleasure for all of us to have Professor Marcus Watson with us. I once again welcome you, sir, for sharing your knowledge with us. I now request Professor Marcus to start with the session. Over to you, sir. Sir, your mic is not on.
Dr. Marcus, please unmute yourself. Please unmute yourself.
Okay, I've got that. I found where the mute is. Okay. Okay, so what I'd like to talk to everyone today about is if I just shrink this down, the use of simulation and games in training for tasks that are very hard to define. So this is ongoing work that was led by Professor Mark Oswell, who was the inventor of the initial hazard perception assessment and has worked collaboratively with quite a large team, especially Dr. Andrew Hill and myself, on how we can design training to improve safety for drivers. So when we talk about types of skills, we need to actually think whether the skill is a technical skill or something human factors refer to as a non-technical skill. So the difference is technical skills are very deterministic. We can be precise about given a particular input, a process, we will know what the output is. And many of these skills have been based from the lessons in aviation, such as the operations of an aircraft, and that has transferred to other areas such as surgery or the actual skills to drive a car. Non-technical skills are the things that exist outside of the procedural mappable relationships. So they're commonly described as things like situational awareness, leadership, communication, teamwork. But they equally apply to areas such as the visual arts. So we can agree upon a piece of art, whether people find it appealing, motivating, even to the extent where some pieces of art are immediately recognized as striking. But we can't actually teach people to be able to produce the equivalent. The same would be for music, creative writing, and very importantly, games design. There is a component of design that is technical, but it will never work unless the design team or the designer has mastered the non-technical components to understand how it works. and some people might use the words like intuition. They may use words like craft. But the reality is what we're talking about is a function of the brain to perceive and model what is important to the design. Now, when we're thinking about how to design something, we need to understand what it is that makes the difference. So driver training has been worked on for 40, 50 plus years to try and improve safety in cars. And what we've learned from that is that training drivers to drive their car better, so to be able to handle the wheel, the gear stick, the brake, does not reduce car accidents. And in fact, it can actually increase car accidents. So surprisingly, racing car drivers have as many crashes on the road as the average driver. And the reason for this is they can drive faster, they can handle corners quicker, but they're less, where we would expect them to be less likely to have accidents, the issue becomes it's their ability to judge situations of things that would predict the need to slow down or to brake. So to design a course to train people in how to drive better, we need to use the right levels of fidelity. And there are many car simulators out there. And the issue is we've demonstrated, or people have demonstrated, they can work with extensive courses. So 2 weeks of simulation training in a car will have an impact on the probability of you having an accident. The problem with such courses is the cost and the time involved to actually do it for a very, very small return. So what's innovative about this approach is actually thinking about the fidelity. And what we use here is real world video footage of crashes and near misses. So near misses are where cars could have collided if one or more of the drivers didn't react to the situation. We focus on the skills that predict crashes around hazard perception, even though we cannot truly define what it is about those skills. So we know some components about the things that predict about the safe distance between yourself and the car in front of you. We know about where to scan the road, but what we don't know is how people deal with the very complex environment found in driving. We use a real world transfer, and this is really important for anyone working in games, is actually to think about how will the skill go from the game to change people's actual behavior. And there's a lot of literature on how we forget and how soon we need to transfer from a simulation or a game into the real world. So a lot of this training is about that concept of being able to take what we do in the simulation and then apply it to the road. And we also work very heavily on forgetting inoculation strategies. So there are many simulations, many games where people come out of it having a strong emotional experience and they think they will change their behavior. But within a week or 2 weeks, they're already starting to forget about the things that motivated them and the things that they learnt that would change their behavior. And the final thing is the planned use, the deliberate practice. So everything that we've got in this around the gaming, as well as the activities, is all about a deliberate practice of going from particular cognitive focuses. So that includes predictive skills, that includes reflective skills, That includes skills that are associated with being able to describe your current situation. Now, just as important as understanding how to map the cognitive components of our design, we also need to understand when we take something from an activity from the real world and put into a simulation or a game, what is it that we don't include? And these assumptions and these key bits of information in the real world that we are either deliberately removing or leaving out because it's difficult to achieve will influence the overall outcome, and it's very important to note these. So, for example, in this training program, there is no vestibular feedback. So we don't feel the acceleration of the car, we don't feel deceleration, we don't feel the G-force as we turn. There is no haptic feedback, no steering wheel, no accelerator, and probably just as important as the steering wheel and the accelerator, there is no car seat. So that gives us an orientation to the forces that are acting on us. The program also does not include the ability for head rotation or peripheral vision. So there are types of accidents that would be avoidable if you were doing head rotation or looking in your rear view mirror that would not be covered by such a training program. However, we have left this out because they make up a tiny minority of accidents where the driver can actually prevent them occurring. There's also incorrect information when we build a simulation that we need to be very much aware of, and how that may lead to negative transfer. So in our case, we're dealing with a dash camera that's offset from the driving position. Now, at distance, this probably makes no difference to the driver's assessment, but for activities that are close to the car, the positioning of the camera in what would be the middle of the car will have a negative transfer to the driver's position, either on the left or the right-hand side of the car, depending upon which country you're in. So there is a risk that that could have some negative training effect. Other issues are really important. Image quality. So color accuracy is really important to consider. The pixel density. So most of the dash cams are reasonably low resolution compared to the resolution that our eyes work out. And there's also the impact of frame rate that can actually distort the way we perceive temporal things occurring. So if you think about a game of Monopoly, it is a huge abstraction from the concept of real estate and economics, but has the power to give you some insight into the advantages of wealth, starting from a position of wealth, and how wealth accumulates more wealth. But it doesn't give you a really detailed concept of how economics works, because things like taxation are not there. Things like competitive approaches are replaced with dice rolls. In the same case, in terms of driver simulation, we need to understand how just using real world footage is different from really being in a car. And this is further complicated if you were to want to take, for example, the driver and train them in a simulated environment where we're building a complete virtual world for the drive. To what extent does taking away the workings of the real world reduce their ability to build effective mental models in the simulation that would transfer to the real world? Simulations and games do allow us to augment information. So they actually have the ability to provide information we can't truly get in the real world. So, for example, pre-activity briefings give us the ability to focus the participants' cognition on the task we want them to learn. When you're actually driving a car, there are many distractions and components of driving you actually cognitively have to deal with, whether it be for an early driver, learning to use the clutch, the gear sticks, the steering wheel, the indicators, learning to be able to look over your shoulder for a turn. All that is removed, and we're able to focus people on the actual activity by giving them a briefing that directs their focus of cognition. We also have the advantage of feedback methods you can't do in the real world. So repetition. So to be able to see something multiple times allows us to focus and get a greater insight. And the ability to rewind allows us to understand what we missed on the first time we actually conducted a task. Activities such as pauses are crucial for people to understand and process information. And again, this is crucial to any type of game-based interface where you want people to think and process. So for example, in a competitive game of diplomacy, the ability for someone not to interact but to pause and think is crucial to their ability to make good decisions. Similarly, for driving, the ability not to have to move forward but to actually think about what happened, what could be different, is really crucial for you to build a stronger mental model. Other activities such as voiceovers can be done to a certain extent by a driving instructor, but are much more powerful in a training environment where we know ahead of time what is actually going to hurt. So to happen to the participant. We also have, in the way of computer-based simulation, the ability to highlight in ways we cannot do in the real world. So an instructor can verbally describe something they want the driver to look at, whereas in a simulation, we can actually circle the object that we want them to look at, taking out all the cognition required to process narrative information into a visual spatial context. There is also the ability to use equivalent examples. And again, this is something not used in a lot of games about learning, but is crucial to understand complexity. So a particular type of accident may occur in slightly different ways that are critical for people to be able to recognize the precursors to that accident. So what I'm going to do now is take you through some of the learning examples, the way we actually teach this. And then after this, I'll go into some of the evidence that we have to suggest this works very effectively. And finally, I'll come back to how these types of approaches could be applied more broadly in games. So the first thing that we want people to be able to do is actually understand how and why crashes occur, to get them to actually think and develop mental models around what are the problems about human decision making, about the physical limitations of the road and the physical limitations of vehicles that will influence the chance of a crash occurring. So in this case here, this is one of many examples they will get. In some cases, the examples include the vehicle that has the dash cam being involved in the crash. In other cases, it will observe the crash. And here we have the concept of 1,000 years of driver experience in 3 hours. So what we're doing is condensing down the number of crashes that you would experience in 1,000 years. So on average, a person is involved in Australia in a crash once every 10 years. So we give people over 100 different types of typical crashes to build up that strong mental model. So in this case, what the student is required to do, or the participant is required to do, is they watch the accident occurring. They then have to verbalize what they thought was the causes of the accidents. And then they see the expert review of the accident. And what we're doing here is priming them to recognize all the things they actually missed. So for example, the traffic sign that was available earlier, and these are, sorry, a condensed version of the training, students won't even notice, participants won't notice. So although they will have processed the information, they will not have retained the information. But seeing why that information is important in context of the accident that occurs 2 minutes later, then allows them to start developing a mental model about what information they should be trying to find and retain. Now, analyzing is one skill, but the real skill we want them to do is to try and predict what happens next. Because there's no point having an accident and then being able to explain why you made the mistakes. What we would prefer you to do is to be able to see the precursors to the accident and avoid it. So here we use a range of accidents and near misses where we will actually pause during the activity and get the participant to predict as many possible outcomes as possible. Then we will show them the actual outcome, have an expert's opinion about what the alternative outcomes could have been, and show them similar situations where the alternative outcomes occurred as the experts predicted. So what happens here, rather than the participant learning a mental model of a particular incident mapped onto one particular event, they learn to search for possible events that can occur. And we build this up over a period of 3 weeks. So there are 3 hours spread over 6 weeks. So there will be a range of different sessions as they go through the process. Now, another one is very important, is their ability to grab information and be able to assimilate it. And one way of doing that is a commentary drive to actually describe what's going on at the time. Cognitively, what we're doing is increasing the load on the driver because they're having to verbalize their situation awareness. At the same time, this is very powerful if we can give them a comparison against what an expert could achieve. This then allows them to gauge their actual driving experience rather than their belief about their driving experience. So another version that we actually do is the ability to detect and see how early they detect a potential risk compared to the average person and then compared to the expert in order to give them the ability to assess how well their situation is compared to the average driver. Oops. And I'll just run through both those techniques now. So the commentary drive is actually quite a bit longer than what we're showing.
Marcus, if you think we can't hear anything.
Oh, my apologies. I'm not sure why you're not getting the audio. Thank you, Elizabeth.
That's fine.
That means you'll miss the other commentaries.
Yeah. I
Just
suddenly
for the
realized
record, I could hear
we've been
both of
doing
you.
something.
I could hear both of you, Marcus and Elizabeth.
But
Yes,
could you hear
it's
the actual
commenting on the
commentaries?
video and it's not showing up.
Yeah, once in a while for long pieces of time, I think while the video was on, you did not speak.
Okay.
I think you need to select share computer audio when you share your screen, Marcus. I don't think you can change it once you've started. You might have to back out.
Okay.
Reselect share, and there's a box down in the bottom left-hand corner.
Oh,
To
good.
the
Flip is
bottom
here.
left-hand corner, enhance for video and share audio. So
Share
close the
sound.
screen.
My apologies. Would you like to go back and see those again then? It might be worthwhile.
Yeah,
Sure,
because
please
it
go
will
ahead.
make more sense.
Yes.
Sorry, I was slow to pick it up.
My apologies for that, people. Okay, crash analysis. So what we're doing here is the participant, their job is they'll see the video, they're to think about and say what they thought were the causes, and then they'll hear the expert. Oh, no. Now, why is that not working?
That's it.
Is that coming through?
Sure.
Not very loudly.
Tell me how it goes for the expert.
A crash occurred when a heavily loaded flatbed truck ran into vehicles that were stopped on a highway. Other vehicles travelling behind the truck were also involved in secondary collisions. There are a number of things that could prevent this type of crash. First of all, drivers need to be aware of their surrounding environment. There was a sign earlier which warned of the slow traffic. This means that we could anticipate and prepare for a change in the traffic conditions. Another clue was the backed up traffic, which was visible when looking further down the highway. The driver of the flatbed truck needed to be particularly cautious, since heavy vehicles require additional time to brake safely. Other drivers also need to be aware of the longer braking distances of heavy vehicles and give them more space. Following too closely blocks the view of the road ahead and reduces the chance of avoiding unexpected events. The following distances for many of the vehicles in the footage were too close given the speed of the traffic.
Did that come through clearly?
Yes, it did.
Yep.
Okay. The next one. What happens next?
A cement mixer has just pulled out of the road on the right and the lights are amber. We already know that there is a white car concealed on the far side of the cement mixer. Given that the lights are changing, the cement mixer is already pulling out and the white car's view of us is likely to be obscured, it's possible that the white car doesn't realize we're here. This means it may well pull out into our path, even though we can infer that it would be entering the intersection illegally because the lights are amber for the camera truck. Just because a maneuver is against the road rules doesn't mean that people won't do it. We need to be ready to take evasive action if the white car does decide to pull out. Also, there's a pedestrian waiting to cross at the lights where it's possible they could step out. Even if the pedestrian doesn't step out, they may be at risk if that white car pulls out and vehicles end up off the road as a result. Looking further ahead, there's a road on the left that we ought to monitor in case something emerges from it. The expert predicted a road user might pull out from the left. While this didn't happen in the main clip, here's another clip in which this did happen.
So sound is so important to the clips having the fidelity to have the emotional response that primes memory. Oops, and driver commentary.
Get ready to generate a running commentary out loud to the following new clip.
So the participant will actually generate their commentary before they hear the expert's commentary. So it's quiet now, but we would go through a period of them seeing what happens on the road, and then immediately after they'll get this.
Now it's the expert's turn.
Pedestrians on the left, monitoring. Red car changing lanes ahead. It might cause the silver car to slow down. Traffic lights, intersection ahead. Silver car braking. Street on the left, monitoring. Silver car indicating to change lanes. Lots of oncoming traffic in its way. Will definitely have to stop. Slowing down to stop behind turning vehicle. Monitoring parked cars, oncoming vehicles, pedestrians and traffic lights.
Okay, let's see some example crashes that might result from some of the things that the expert talked about. The expert mentioned monitoring the street on the left. Even though the traffic lights are green, it's still possible that someone might emerge, as they do in this clip. If there's any opportunity to avoid a crash, then we want to be able to take it. The expert noted that there's a vehicle stopped in the lane ahead that requires a camera car to slow or steer in order to avoid this sort of incident.
Yay.
Again, just because there's a green light at this intersection, it doesn't mean that there's no need to monitor left and right. Some people do run red lights, and we want to be ready to take any opportunity we can to avoid being hit when it happens. At this point, the expert noted that the car ahead was slowing to turn right. Here's an example in which a driver failed to notice that someone in front of them had slowed in preparation for the same maneuver.
So the ability in simulation to give the what ifs that we can verbalize as a driving instructor, but it's totally different if you see it for real, has a deep impact on where people focus. Now, in this final one, what we're doing here is we're trying to get the person to assess their skills compared to an expert and the average person in the population. So their job is with the mouse is to indicate as soon as they see a potential hazard, then they'll get to rewatch that material and see when the expert noticed it and when the average person noticed it, and they can compare their result with that of an expert or the average person. Oops, sorry. Now, why is that not playing? There we go. So an expert saw it there, the average person saw it there, and the participant didn't see it till afterwards, which immediately tells them they're below average in their skill to recognize risk. We then have one of the most important activities that's often missing from games, and that's the transfer to the real world. So we have 3 of these activities that transfer very easily to the real world, and we require the participant to select one of these 3 activities every time they hop in the car and focus on that activity. So, for example, if we're building a game around business to get people to think differently, if we haven't built that game contextually into their work, it's highly likely what they learn in the game will not transfer to the real world, unless there is a way in which they can deliberately practice the embedding of the learnings from the game. So the actual course itself, it's a 6 half-hour sessions, 1 a week, spread over 6 weeks. So that's a total of 3 hours. And we actually ran this as a with a control group, the waitlist, who were there to do the course later, to be able to compare their ability to predict accidents. Now, the hazard test used here has been validated that your performance on the hazard test predicts the probability of you having an accident. So we have a very reliable test, and that's really, again, critical to any type of design, is that we can assess with something that is meaningful to assess with. So the trainees, their response time was significantly faster. And if you think about how much faster this is, we require in Australia people to have a 2-second interval between themselves and the car in front. And the response time differences we're getting here are nearly 2 seconds. So you're more likely to spot an accident well before you even need to see the person in front's car's brake lights come on. So it's highly significant in the ability to recognize and respond earlier. Their ability to predict events is much higher, significantly higher than those people on the wait list, so those who are just normal drivers. Their ability to judge following distance has improved in the right direction, so they would actually select to have longer following distance. Not all things came up significant. So one of the things was that their video speed choices were not significantly better. And neither was their gap acceptance scores significantly better. And there's a couple of reasons that this may be the case. So the 2-second gap that we recommend in Australia was designed in a period where brakes were nowhere near as good as they are at the moment. And so it's highly likely we've learnt around braking that we can actually be closer and still be able to successfully brake. So bringing it back to the gaming considerations, we did use some gaming concepts in here. They were not the dominant method of learning, but they were also very important to what we actually did. So we had some reward systems in the actual game where they got little on-screen rewards for it. At the end of the game, if they completed everything, they got to see more accidents. And it turns out that most young people are quite motivated to see more accidents. But some of the things that we did that was very effective was context. So they're learning to drive. The transfer task means that they can actually see how what they're doing in the game and the simulation transfers to the real world. We had the right level of fidelity. So if we had to have done this as an animation, we probably would have had no transfer and skill. So unfortunately, at the moment, we don't understand the level of detail required for people to process all the information to make the right decisions. So by taking away detail, that as we would do in an animation, even the best quality animation is going to be taking away real world detail. We lose out on something that is critical to the transfer of such a non-technical skill. We use anticipation. So anticipation is a critical component of all games. If there isn't a level of uncertainty in it, a level of expectation, people will disengage. There is problem solving. We actually love solving problems. We like feeling uncomfortable. We like solving problems. We don't like it when those problems have real world consequences. So that's when we back away from problem solving. There is a series of feedback loops that we use that are absolutely critical, and these need to be in all games. So there are many people who design games that fail because they haven't thought about the feedback loops and how once it becomes apparent you're not as good as where you thought you were, what is the ability to know that you'll have another opportunity to get better, for example. And those small rewards are important, but highly variable. And the reason I say that is it comes back to context. How important is it for you to do well at the game or the simulation is critical. Who is involved in the game or simulation is critical. So there's a paper we've got that's about to come out that examines what is the impact of parents being involved in the training and the transfer task. And the outcome from that is the participants, the young drivers, do much better than what we present here. But not only do they do better, the parents do better at hazard perception. So that shared experience is again part of that reward around context. Who is it important for you to impress? And for a young driver, impressing your parents is important. For parents, knowing that you're actually better than your young drivers is probably just as important as well. So there is a strong motivation to do well at the activity. Okay, I will open up to questions there.
Please ask your question.
Sure.
You've got one in the Q&A, Marcus. Can you see it?
Oh, yep.
Yes. Can I read?
What if someone is trying on his own, alone, based on this simulation, actually makes an accident? So you wouldn't, this would not, in Australia, would not be the only component in your driving. You still have to pass your driving assessment. What we know is that no one gets worse from this training, so it's not likely to contribute to an accident. There are things that are of concern that we have looked into because we've taken away the rear view mirror. Does that change your observation behavior because you become focused on the activity? We have no evidence that that does change your behavior. The areas where this would be unsafe would be, for example, to take what we've built in Australia and transfer it to India or to Russia or to the UK, because that context is crucial. So the way other drivers drive is different across the world. So you're not just predicting the vehicle limitations, the environmental limitations, you're predicting driver behavior. And that would be the risk of such a game, is taking it to the wrong context.
So here's a challenge for you, Marcus. How would you take the underlying principles of what you've done and apply them to develop a similar tool for India or Russia or Thailand?
We would do the same. Yep, the same process. So we would want to get dash camera videos from their environment. That would be crucial. We would look through the types of accidents that occur. I suspect that is not that different, but the precursors to the accidents are. So the environment is really crucial. So for example, a rural Indian setting is going to be different to a city setting, and therefore we may need a broader database to cover the full breadth of driving skills. We would then grab a group of experienced drivers, preferably experts. So in that case, people we've used in the past are racing car drivers, police who specialize in road activities. But we've also found that what we can get is an expert panel to assess each video, and then we get a broad view. So what we find is our best experts can give us 70% of the possibilities. Take 6 experts or even 3 experts and you'll get close to 100% of the possibilities. So we would do the same process for that. So the types of accidents, the biggest variation will be, I suspect, animals, and potentially things like bicycles or non-powered vehicles will be very different across those 2 settings. So we would have to look at those types of things, and we would build it based on the local context.
Okay, I request other panel members to please ask the questions if they have.
Dr. Dimitri, please ask the question. Please unmute yourself.
Sorry, I couldn't understand that question. It was it sounded like there was interference.
Sorry, I invited Dr. Dimitri to ask the question. Request him to unmute himself.
Hi, Marcus. Philip here. Good presentation. I missed it when you did it a few weeks ago, so it's good to catch up. Just a couple of quick questions. Firstly, the average that you showed in that last video, how did you come up with that? And then second question is in terms of environmental conditions. So the first video had, it looked like it was maybe a wet road, I'm not sure. But did you include videos that just had environmental conditions such as wet roads, puddles on the road, that kind of stuff for people to observe?
So I'll deal with the environmental condition. We use the available footage rather than try to train people to think in the wet, you need to think about this. In the dry, you need to think about this. We would bring that out as a contextual thing. And what we found is training people around setting your context first doesn't develop the full mental model. So it is about having that experience. And I'm going to go back to a healthcare example. So seeing 1,000 gallbladder operations is crucial to you being good as a surgeon to remove a gallbladder. Now, you're not going to see 1,000 gallbladder operations before you're the lead surgeon doing the gallbladder removal. So it's about your mental model being able to construct the complexity of variance there rather than us being able to define it for you. Because the reality is you have to have the plasticity in your situation awareness to decide what's important in that current context. So it's very important that we don't try and reduce it down to these are environmental factors, these are behavioral factors, these are vehicle factors, that it has to be contextually put together in every single event as what is there at the time. And the advantage of that, that's easy to get from dashcam. Your first point, sorry, Phil, was your question?
When you showed the average,
yeah, okay.
How did you get the average?
So the average can be from a pilot study. It's the normal way we will come up with an average. So before we would release any training, we would run it through a large number of people first, and we would grab that study. So in this case here, we have a whole range of prior tasks from an honours experiment that we're able to pull the average out from each clip. So that's reasonably good. Interestingly, when we run a small number of drivers, we get a very similar average to a large number. So there is a big difference between the expert and the average driver. And remembering that the average driver is not the average learner, it's the average driver that we want to focus on.
Yep, got it. Thanks.
Dr. Dimitri, you had a question? You'll have to unmute yourself.
Mute.
I'm allowed to ask question, yes?
Yes, of course.
So it was very interesting, and pieces of pleasure even comes from your report because it is scientifically based and try to make a big, huge observation of things. You have results. That is very, very unique, of course. By the way, if you will send us some references of your articles, we will have chance to read it more carefully. Now to question. If we will come from average things to very certain, each person usually interested in himself first of all, or family or kids and so on. Question, do you have materials about age of your drivers? Who is following education? It is a brain education. It is not a muscles education, first of all. It is a young people or enough bald-headed as we are. So what kind of analytical work comes from your big experience, several up to 50 persons, as I understand? It is my question. Thank you.
Some of Mark's, so Mark Horswell, Professor Horswell, has been working on this for nearly 30 years. He has, I can't remember the total number of studies, but it would be something like 20 plus studies with very large numbers, and they address everything from learner drivers to the elderly. So we know the hazard perception assessment works for all groups, and so does the training. And in fact, experts improve their driving based on the training. So the simple fact is none of us have experienced 1,000 years worth of driving. And what we've done is we give that, so experts will still improve no matter what their age is.
So thank you. If you will give some reference to your articles, of course, we will use it, especially in the area for me more, with much more familiar. It is a road accidents with animals.
Okay.
So
I will make them available.
If possible. Thank you.
Yep.
Is there any other question from, I would like to read one question in the question and answer tab. Question is that, how to easily implement hazard perception training in your organization today?
That's interesting. It's our current task. How do we get every person to do this? And then the task after that is to find out how often do they need to refresh doing this. So at the moment, we would be looking at talking with insurance companies to get people to do this. So you would get a reduction in your insurance premium if you have done the assessment. And we would expect it would reduce road accidents by 24%, but that actually may be an underestimation because it would actually transfer, if everyone was to do it, that is an cumulative effect rather than an individual effect. And we haven't been able to model that yet. Trying to get governments to mandate such training is actually quite difficult because people already believe the effort to getting a driver's license is difficult enough. And they have, in Australia, there is a minimum number of hours of supervision you must do, minimum number of hours on the road. But what we would suggest is actually you could reduce those number of hours if you were to do the hazard perception test and the transfer tasks. So one of the other things is to think about this as a method of training that would apply beyond driving. So we could apply this to any complex task where you can capture deep video footage, so enough video footage to have the variety of examples, and where you have a measurable difference between novice and expert. So the areas we're looking for in healthcare include communication-based tasks, clinical tasks such as cannulation, tasks that are team-based tasks as well. So understanding when to actually speak up in a team situation. So the technique is very powerful because it's about compressing experience. And it's about compressing that experience into a way that you have reflective feedback mechanisms. So the ability to repeat and to rewind are absolutely crucial, and we can't do those in the real world.
Okay, one more question is from Professor R.C. Bhattacharya, Vice Chairman, Globsin Business School, Kolkata. And question is that what if someone trying on his own alone based on this simulation actually makes an accident?
I think it's covered that.
Yes, so we did cover that one.
Already done.
So it would never be used independent of other driving skills requirements.
It's already replied to the question.
Okay, one more question is there. Do you think that using this simulator, one can even get along with the driving license?
It would be sensible to build it in. So we know teaching people to be better at the technical skills of driving a car doesn't reduce accidents. Once you get to the base level of driving a car, it has very little impact on it. So this is about your ability to make judgments in complexity. And yes, it should be in there, but it needs to be contextualized. So the course we'd build for America would be different to Australia, and the course we'd build for India would be different to Australia, because your conceptual risks are different, your driver behavior is different. I had a wonderful experience in Indonesia where drivers will and hit their horn at the oncoming traffic, and the oncoming traffic will pull off to the side of the road. And that's normal behavior there. And if everyone does that, it's actually not that unsafe. But if you did that in Australia, it would be disastrous. So we have to contextualize those components. And that's really important if you're producing games for people, is to think, will it transfer? What's different about their work environment that's not going to be compatible with the way I've designed the game? And other areas would be the military, for example. There's much training that we would be able to do, because if you're not in fighting wars, how do you actually provide that intense experience. And I think we have some great ways to do that. Vinod, you had your hand up.
Yeah. Simulations and games are best for very complex situations, and visualization like this or an animation like this, I think, goes far better. In the sense that it could take on something very complex, something very large. I had some 3-4 ideas in mind, such as to help people understand what is plagiarization and how to avoid that, how to predict the weather. That's also very complex. Or maybe in our own fields of game design and facilitation, I think we could have videos or animations like this to explain and to understand. As you all know, the picture is worth 1,000 words, but an animation like this is worth 1,000 pictures. In management education, we depend a lot on case analysis. The case is about the past. And although we often say that if you don't know your history, you're likely to repeat it, I'm not very much confident that history can help me avoid accidents of the future. So therefore, if you can provide or create animations like this, probably we could make it the base or the heart of the courses that we teach in college. And therefore, we teach from there. It could be game-based learning and practice.
So I totally agree, Vinod. We've actually done some piloting work on this.
Oh, lovely.
Where we've abandoned lectures and tutorials and moved to 4-hour workshops where the students will participate in a range of activities, including peer marking, to understand all the processes involved in the learning. Now, fortunately for us, the topic we were doing was on cognitive learning. Okay. But we had a massive impact. So we took, on average, grades went up 12%. The assessment bank was the same assessment bank before that's been used for years before. So we know that those prior marks were steady for years. We have a massive increase. We actually had a decrease in workload for the staff because it was done in the context of the workshop. The students got immediate feedback. So all assessments were done at the beginning of the workshop on the prior work that we had conducted in the course. And we would immediately give the answers and have a discussion with the student about their alternate answers. So there was no administrative emails. And then they would go back into problem-solving components. No lecturing component went for more than 20 minutes. And the goal was to make as many of the lecturers 2 to 7 minutes as possible. The final component was every student had to be involved in developing a teaching component of the course they'd just done to demonstrate deep understanding. So you can use these same techniques. It is really important to use the video camera so that they understand where they're up to. The ability to capture, to reflect, and to improve is critical. And we're still lecturing at universities the same way we did 150 years ago. Mm. But we have the capacity and we know a lot more about learning to do things differently. There's just a reluctance to actually get up and actually do it differently, because I think most people are scared of what change will be, whether there's going to be some loss associated with that. And I don't think there will be. I just think there'll be less workload, greater satisfaction, higher levels of learning, and people will achieve more.
Thank you, Marcus. You also answered my question, which I did not ask. Were your students involved in the development of the animations? Thanks a lot.
Okay.
Is there any other question from panel members?
There is one more in the Q&A.
Oh, what have I missed?
The simulation affect the improved manner of our own to search for solutions?
Yes, I think it does. So not so much this work. The other work I do is around the design of technologies. So we're in the process of trying to get out to the world a breathing mask for patients that is cheap, so less than $15 US, that is frugal on its use of oxygen and is safe for the patient and the clinicians around them. We have used a process of simulation rapid prototyping to actually go through and test the device. And I think just about all our assumptions were blown out of the water about the way things occurred. So we've learned that people don't cough the same, that cough is highly variable. We've learned that, and when I say highly variable, some people will vaporize all the moisture that they cough, and other people will cough out to 3.9 meters. So that's well outside of the WHO World Health Organization recommendations. We've learned about our assumptions in design, about physical forces, communications, that some of those weren't actually behaving the way our mental models thought they were. So I think it is a very effective way to, as a designer and a developer, to learn about your own work environment, about how things actually do process and work. Sometimes it's a little confronting. Sometimes you see yourself doing things that you didn't think you did. And that can be uncomfortable, but you can then change it so you don't do it in the future.
There are a couple of other questions as well. Perhaps, should I read them out to you?
Yes, please.
Does simulation affect or improve the manner of our own research solutions?
Sorry, I was just trying to answer that one. Yes, I think it does. And I also think games do. So we have often, and Elizabeth does a lot of work on this, thought-based games. So thought experiments are crucial for us to challenge our own core beliefs.
Mm.
And the other question was, what is the role of sensors, intelligent transportation, drones, and satellites in simulating exercises?
I think the interaction between intelligent systems and humans is totally understudied. We're not thinking about how they work collaboratively, and we should be, because at some point or other a human is responsible. I think drones may give us, and intelligent systems may be able to give us better perspectives to build stronger mental models. And again, we're not actually using that well at the moment. Most of the work around the drones, intelligent systems, is about how we replace humans rather than how we augment humans. And we need to do a lot more work on that augmentation, because it's absolutely critical to know about the limitations of the human model to process information rather than the intelligence of the drone to do something. So how do we get that really good collaboration?
Okay, thank you, sir. I think we have covered all the questions. So it was, thank you, sir. It was a wonderful session for all of us. You have very well discussed the use of knowledge elicitation techniques, the fidelity requirements, the application of cognitive learning theory and gamifications. So I once again thanks to you for giving so much knowledge about the gaming. Now I request founder of Mentis, Dr. Vinod Damblekar sir, to propose words of thanks.
Thank you, Rupali. Marcus, you took us into the future. You showed us another view of simulations and games in a visualized form, which was more interesting, more powerful. I personally will take some of these ideas for my own understanding that complex systems are best understood by simulations and games. You also explained a number of questions that came through, especially with respect to drones and how to avoid accidents. Thank you very much. We hope that maybe you'll be with us back again some other time very soon. To all our other participants, we've had a good crowd today. I hope you'll visit again. Thank you very much for coming here. Thanks very much to the Vaishnav University for organizing this as part of the ISAGA 2021 conference exercise. It has been very fruitful. It has been very enriching and very illuminating. We have looked at 23 different views of simulation games so far through webinars, and I hope we'll get to see more. We are missing the Vice Chancellor and the conference chairperson, Dr. Pinder Dar. We hope that we'll see him in the next webinar. And I hope to see all of you again in the future. We have 5 more webinars to go. Thank you all. Have a good day. And to all of you who have been here, very much. Thank you very much. Please come again. Thank you.
Thanks, Marcus.
Thank you.
Thank you.
Very good to see you.
Take care, everyone.
Thank you, everyone.
You too.
Thank you. Thank you all for being with us for the webinar. I request all the participants to please fill the feedback form as mentioned in the chat box. So see you soon for the next webinar. Till then, take care and have a nice time. Thank you so much.
Thank you.
Thank you,
Dr.
Dr. Marcus.
Thank you. Thank you, Marcus. Thank you.
Thanks.
Thank you, ma'am. Thanks a lot.
Thank you, sir.
Dr. Dimitri, hi. Thank you very much for being here. Tito, long time no see.
Bye-bye.
Bye. See you next time. Come back soon. It's only 7 o'clock. Did you have your breakfast?